Well, good morning, everybody, and thank you for the invitation for speaking at the Automate conference. It's good to be back in person. Today, we will be talking about deep learning and vision AI, and in particular on how these fundamentally new technology are changing many aspects of manufacturing as we know it today. And if you work like myself in a company, then many of the discussion with your coworker daily might turn into the news, and the news have not been kind to us, in particular in the manufacturing and the supply chain sectors. Disruption caused by COVID-19 and other events such as the Ukraine war have created a lot of strains on our sector. And with the occasional good news, in particular on the automation and robotics and artificial intelligence seen as technology that can help us to overcome some of the issues that are originating through in these events. In reality, the COVID-19, the Russia-Ukraine war are relatively newcomers in a very long series of issues that have plagued the manufacturing sector for decades. Starting with the pressure to improve, which is a never-ending, task or a never-ending element in the manufacturing sector. So increase quality, efficiency, decrease waste, and so forth. Pressure also to increase the SKU offering, so new products, quick turnaround, and quick reconfiguration of your production facility. In the backdrop of all of these, waning workforce and reshoring, right? So factory and jobs are back in the US and Europe, or want to be back at least, but it's not clear who is going to eventually take those jobs. And on the backdrop of these new issues, COVID-19, Russia-Ukraine war, issues in manufacturing, supply chain, and many more disruptions. So the traditional way of solving this problem, which is adding people, is really not viable anymore. So we have seen that the number of people available to work in factories is decreasing. Just in US, the job deficit in this sector is supposed to hit 2.1 million by 2030. Even if they are available, human workers have high cost, inconsistency in quality, such as, for instance, the inability to have visibility on what they're doing and what are the decisions that they are taking, in particular, in tasks such as quality inspection and so forth. So let's take, in fact, quality inspection, which is a discrete task which involves checking, measuring, and testing to ensure that products adheres to quality criteria. What's the cost of a bad product? So an estimate for a food company, at least, for a product recall is $10 million per product. So it's a costly mistake, and they happen and they happen very often. 15 million is the number of vehicles recalled for electronic component defects. I think that's in 2022. In 2020, the US manufacturing quality inspection employees number 356,000, and the projected reduction in this workforce is 47,000. So there will be a very sharp decline. And simultaneously, we are seeing the projected number of manufacturing machine vision system by 2025 reaching 100 million. So it's very clear that the trend is to replace more and more human workers with machine vision and with artificial intelligence, leading to a growing market size for machine vision in the manufacturing quality inspection. This is really not new. It's a deja vu that people like myself have witnessed in many other sectors. So in particular, in our work done in robotics with NASA, the fundamental idea was very similar. You don't have availability of people. In this case, you couldn't send people to Mars, or we can't yet. So you have to have humans take the job. You have to take a machine, take the job of a human, and perform a task, not in this case with the brain of an operator, which is in the case of Mars, millions of miles away from the robot, but have the robot equipped with his own brain. So what does that entail? Entails the ability to process multiple streams of information, camera, motion, temperature, force, pressure, humidity, many sensors that this robot have, and of course cameras, interpret this information, learn from it, and then output the processing to a human operator. And this has to be performed with a lightweight software which has to run directly on the machine, on the device, without accessing the cloud. And more importantly, the output of this system have to be transparent and easy to use for human operators. So all of these are very similar constraints and very similar demands that the industrial manufacturing sector is facing today, where as opposed to having an unavailable worker or a very scarce, hard to find worker donate its brain and its body sometimes to the operation of the machine has to perform this operation in as much as possible independently from the human operator, having potentially its own brain to deal with all this stream of information that is coming out of from the machine and perform tasks independently from humans. Thankfully, this is not a new problem. It's a problem that at least one very sophisticated machine has already solved, and each one of us has one in its own skull. The human brain, about 100 billion neurons, 250 trillion synapses. Many scientists, I was one of these, have fundamentally reverse engineered the fundamental equation that describe the working of individual neurons, network of neurons, able to produce behaviors and perception that are then translated into software that can run on ubiquitous, very lightweight and low power processors that today can be embedded into various devices, including robots, and industrial machines. So the technology that this artificial intelligence or deep learning has been rebaptized more recently can solve are very similar, but it's progressively displacing traditional machine vision, which has been around for many, many decades. And so to illustrate the difference between machine vision and the deep learning, there is a simple example. So let's imagine we need to classify a cap as defective or not. With traditional rule-based machine vision, you need explicit programming. So you need to define what are the conditions, what are the perception, what are the elements or feature in the image that will lead you eventually to a decision. This is a defective cap, or this is an integral cap. With deep learning, all the intelligence of the program is actually encapsulated in the fundamental equation defining neurons and synapses and the learning rules in these neural networks, and then all that the operator needs to do is to present data. And so very similar to humans, deep learning algorithm or neural networks learn by exposure to data and shape their architecture through the exposure to this data. So there is no programming required to create a rule that leads to detect whether a cap is defective and or not. And because of their nature, they're also very amenable to the sort of qualitative assessment that humans are really, really good at, and traditional machine vision is really, really bad at, or it's very difficult to program to do that. And this is captured by numbers. So the global AI market in manufacturing is growing very rapidly, and the subset of this technology that is grabbing the majority of the shares is, of course, deep learning, which is again a subset of neural networks that I just illustrated the basic functioning of. And among this technology, the split is actually in favor on-premise, which is kind of different than in other sectors where cloud computing is okay. In the manufacturing sector, very similar to the NASA robot example, the processing has to be done because of latency, because of confidentiality of the data, because of cost, and so forth, is preferably done or has to be done at the edge or on-premise. So the whole trend is reinforced by forecasts with the global deep learning in machine vision market supposed to balloon to over $9 billion in 2029. So the trend is set, and just to understand the evolution of the species, we are moving from manual inspection, which is what fundamentally is still done today on the manufacturing floor, using expensive labor, inconsistent in quality, unable oftentimes to identify defects that are invisible to the human eye, little traceability, and sometimes difficult, at least in the pandemic case, for social distancing. And then the other solution is traditional machine vision. Again, has been around for decades, requires a lot of expertise, is expensive, time-wise also to implement. It's very expensive to reconfigure. You have to go back and redo many of the steps that you did on the first time. It's not very flexible, and typically has very limited data record as well. The third step in the evolution is deep learning. Deep learning has the feature of enabling human-like qualitative assessment, human-like judgment, and the ability to just train by showing products, which is fundamentally a huge reduction in time with respect to programming explicitly. Deep learning should be easier to use, no PhD required, to integrate and update, and should be cheaper to set up and operate. And if all of this is true, should enable to obtain 100% quality inspection. So there is no need, there is no limitation to the number of eyes that you can deploy on target to inspect the product. When I say should, the question is why, if deep learning is so fantastic, is not everywhere, right? So why RM Factory is flooded today with deep learning and artificial intelligence-based inspection? Well, the first reason is that technology tends to be out of average reach. So AI and deep learning and neural networks are not super easy to understand, set up, and produce. While in the world, about 36,000 people self-report as expert in AI, the estimate is about 4,000 people really know what they're doing. And I witnessed the emergence of the species of AI expert. I've been in AI for about 25 years. 25 years ago, AI was not as fashionable. Neural networks were not as fashionable. But when they became fashionable, all of a sudden, a bunch of people became expert, self-proclaimed. So that's definitely a factor. The second factor is data. Data is a huge requirement for the majority of deep learning algorithm. But the thing that makes it tricky for manufacturers is that you need a balanced data set that contains typically example of good products, but also an equal sized amount of bad products. And the second class of images is really hard to find because production tends to be good. You tend to have very few issues. And so it's hard to find a balanced data set. And the third one is cost. The majority of deep learning platform require GPUs, which are, you have to fight with the cryptocurrency maniac who is buying GPUs to process Bitcoins. And so that's not super easy or super cheap to find. What manufacturers really need at the end of the day is the equivalent of what WordPress was for the web when in the 90s, it went from a niche activity, building a website required HTML skill set and so forth, to becoming the province of everybody's ability to do, with the introduction of platforms like WordPress that require no knowledge of web design to build, deploy, and then maintain a website. So similarly, deep learning, the set of deep learning problems that today can be solved is kind of constrained by, on the one hand, the amount of expertise that is needed by people to build, deploy, and maintain these models, and on the other hand, by the cost of the solution, which requires training, which is costly, skilled personnel, but also require hardware, and that is more expensive than what other kind of software required. So if we can reduce these two chokehold, which is the knowledge and the cost required to build and deploy this AI algorithm, then we can open the floodgate of applicability of artificial intelligence in the manufacturing space. Well, show me if deep learning is so fantastic. Let's have a look at what are actually these applications deployed in the field. And just our little startup has today deployed, in the field, in factories, deep learning algorithm for the purpose of quality inspection. So these are all deployed application all over the world. I just selected four for brevity. One is public information. So we work with Appetito, where we use our deep learning platform called Neurala VIA, which stands for Visual Inspection Automation, to inspect food trays, in particular to find out if each tray has the right ingredient according to their claim in the box. Another application we are deployed in Europe is baby wipes. Are those packed correctly so they don't reach the store? And if they're all smushed up, they get returned, and with the cost associated with them. Another application is in deployment. It's pet food contamination or the ability to detect contaminants before the pet food is passed into cans and packaged and shipped away. And another one is in plastic, is the surface of the plastic component, okay, before shipping. So these are all solved and applied, and the way we have done this is exactly to build and deploy a WordPress for AI manufacturing that has the ability to build, deploy, and maintain a visual AI algorithm in minutes, right? So all you need to do is collect a few images, you train the visual model sometimes in seconds, and then you deploy and inspect, connect with the PLC, all without any AI expertise, gigi vision camera, using any gigi vision camera available, any industrial PC, PLC, just collecting a few tens of images of good products, right? So all you need is an example of what a good baby wipe package is or good pet food, and then you deploy and make it run in minutes. So the fundamental insight was to make it quick, easy, and economically viable for a small business to invest in this new technology. So an example is visual inspection of a meal. So Appetito is a firm in UK that package about 1.4 meals per year with 1,200 SKU in 14 production line. And so the issue that we helped to solve was reduce or slash the 1,000 complaints per year, mostly due to missing food components, which sometimes is a violation of the contracts. So the solution was deployed, achieving 100% accuracy in detecting trays with missing ingredients. The other one is how to automate qualitative assessment, or in particular, finding contaminants in food. For a Fortune 100 company worked with us for a number of months, and we are now deploying the solution in a couple of dozens of factories across the Americas by checking, by detecting contaminants in raw meat, in raw ingredients, which is a highly qualitative process, which is very difficult to do with traditional machine vision. Furthermore, every camera should have deep learning, right? So we are also working to embed this technology in OEMs. In particular, we are working with Teledyne FLIR with a very inexpensive camera, which is called Firefly DL, with the idea of, you can spend $400, $500 and get a camera that has the ability to be programmed and deployed with its deep learning capability inside an industrial machine or in a production line at the cost and an expertise level that is a fraction of what it used to be just a year ago. But application also bleed beyond manufacturing. The goal was, in this case, to improve logistic applications by optimizing optical character recognition, which is a fundamental deep learning technology on top of a traditional technology, which is OCR, that wasn't working in that particular use case with IHI, which is a Japanese company. So with the deployment of our OCR solution powered by AI, we bumped precision over to 95%. Application across industry vary, and they are very common throughout the supply chain, from the intake of raw material to the production, packaging, palletization, and shipping. So we have either deployed use cases or in deployment in all this sector, from electronics, PCB inspection to barcode checking, surface inspection, food packaging, food processing, components check, and so forth. So if we can check all the boxes below, we believe that AI is ready to be adopted by any manufacturers. The first is ease of use. You need a platform, you need a solution that doesn't require very rare AI expertise and the ability to test and validate inexpensively. That's fundamental. So you need to check the solution without spending a ton of money. And if possible, you have to work also on existing hardware. The second box is flexibility, the ability to achieve 100% visual quality inspection and the flexibility to scale up and down for short runs. And the third one is ROI. So you need to be able to realize the investment, the return on your investment fairly quickly without waiting for years. And ROI is really the most important aspect here, right? And we know that the cost of a recall, the cost of a bad product is very high. It can be money, it can be time, reputation, and more than that. And with a tiny fraction of that cost, that you can today deploy in just weeks an AI solution that can slash down, that can dramatically reduce the risk of actually having a bad product ever leaving your factory. We have designed and deployed solution with a cost varying between 100,000 and 200, between 10K and 200K to inspect fundamentally 100% of the production. So as we are hit with old and potentially new problems, the solution will be a combination of artificial intelligence, automation, robotics that exploits the convergence of three different forces. The first is the availability of powerful deep learning technology that is economically viable for the first time and easy to use by every operator. So that when all of these preconditions are true, then there is really no limitation to unlocking the power of artificial intelligence for manufacturing. Thank you.